Alright, a little intro music.
In the mood with a little intro music.
Haze, produced by Chemtrails.
And there are several measurements on this that you can do. Here's a booklet. For instance, we're measuring specifically, okay, over here, now these are knobs, and I can measure green light, which is visible, red light, which is basically used for photosynthesis by plants, and infrared light. Unfortunately, they don't have UV on here. And then this is the compass, and it's a very accurate. They said this could be used for professional stuff as well. There's all kind of things, interesting things in here. Measuring the angle of the sun, like measuring the red light, plotting green and red light on a sunny day versus a cloudy day versus a. Hey, I decided to do these measurements on chemtrail days and compare, because in science, I have a science degree. You always have a control, which will be the sunny day. I mean, with no chemtrails. And I specifically focused on monitoring haze. So just real quick here, what is haze? A beam of sunlight entering a dark room reveals itself as a bright shaft of white. Close examination reveals sparkles flying through the beam. The beam is made visible when some of its light is scattered into your eyes by molecules of air. Light scattered by molecules of air is called the Rayleigh scattering. The sparkles are caused when some of the light is scattered into your eyes by tiny dust particles floating in the air. Light scattered by particles is called MIE scattering, M-I-E. But these effects are named for the scientists who first described them. Haze caused primarily by MIE scattering is from tiny particles or droplets suspended in the atmosphere. The particles and droplets that cause haze are called aerosols. They include dust, smoke, soot, salt, ice, pollen, spores, and tiny droplets of liquid or whatever. Water that condenses on very small aerosols increases haze and leads to the development of clouds. Haze affects temperature. Haze formed by sulfur emitted from power plants that burn coal scatters sunlight back into space. This kind of haze may have caused slight cooling over the northern hemisphere. It reduced temperatures at the ground because it absorbs sunlight. Smoke haze also warms the atmosphere when the carbon particles in smoke are heated by sunlight. Inhaling the fine particles that form some kinds of haze may pose a health hazard. Now you've got ozone. When you mix pollution with sunlight, you get ground level ozone, which is very bad.
Pollution, like chemtrails, what they're dumping out.
On a hazy summer day, okay. And then, okay, so that's just a little intro there. And for this one, I filled out my data points. Date, time, for green light, red light, infrared light, with the shadow band up and down. And then when you divide the up by the down, you come up with a ratio, and then you come up with the amount of haze. And then you graph those plots. And so that's what I did for different days. Specifically, I did it over the summer, but specifically we're going to focus on November the 13th, where I witnessed a lot of chemtrails. Then the 14th, November the 14th, it was a sunny day, and I did measurements. And then November the 15th, it was chemtrails again, and I took those. And so let's.
And also on the 17th, I had the.
So I got two kind of graphs. I got just a. So like I said, after I got all the coefficients, I graphed it, and I did two kind of graphs. Just a regular point graph, and then I decided to do. I wanted the graph to be linear, so I did a linear regression. This is a mathematics thing, where you get the best straight line. There's a calculation for that, but I'm going to start out with okay. I'm going to start out with this is okay. Here we go. So this is chemtrails on the 13th. Okay, so the higher the number, the more the haze, right?
And this is green light.
Okay. And this is on the 13th also, a 2-point graph. There are two different kind of plots they have in this book. So this is by the way, this is all for green sunlight. This one and this one is the green sunlight. Okay, that's the 13th. And then we'll go to, I skip to the 15th. It's the green sunlight, so you see these high levels here. 15th, 15th. Okay, now let's go to the sunny day for green light. Now you see how the levels have lowered here. And pretty much, look, because that's only 2.7 here versus, versus 4 and 88. Okay, so you see that. Now, we'll go to the linear regression where we make the best straight line through the points to see this better. Okay, this is November 13th, chemtrails regression line. You see it going up. Okay, now we'll go to November 13th. This is a 2-point or 6-point, two different graphs, but going up. All right. And then November 15th, chemtrails, 2-point green.
You've got a pretty big slope. You're looking at the slope of the line. Higher the slope, the more haze.
And November 15th again. Here's our graph. Going up. All right. Now we got November 14th, sunny. Notice it's decreasing here. Okay. That's November 14th, the sunny day. And here we go. See the difference? Sunny, no haze here. Versus, see that? Oops, I was over. Yeah, I left off here. Okay. And then sun, practically flat. Okay, no haze. Alright. And then, let's see, what did I do? Okay, then I went to green and infrared light. Alright, so this is on November the 13th for red light. Alright. November the 13th for the green light. November the 15th, the chemtrails, red light. November 15th, chemtrails for IR, infrared light. Okay, now the linear regression line, November 13th for red light during the chemtrails.
A little bit of a slope, but not much.
Okay, November 13th, infrared, it's going down. Well, this is IR. I'll get to this, my point in a minute. November 15th, chemtrails. November 15th, IR. Oops, back to that. And oops, hold on just a second. November 16th. Okay, now what I wanted to do is make another point here that I noticed is that now this is a big thing I noticed, and I just happened to notice this, and then when I looked up, it came out to be true. But I noticed that the graphs for the green light were, let's go back over here. The green light were larger.
The green light haze was larger than the red and IR graphs.
Yeah, not a lot larger, but they were larger than the graphs for the red and IR light. And I was wondering, I was just wondering about that. And so, alright, so we've done this. Let's go back over here now. So, oops. So then, I don't want this to play again on. I know, like I said, I noticed that the green light graphs for haze were higher for the green light than the red and the IR. So on a hunch, I just looked that up. What's a second? On a hunch, I looked that up. Sorry. And hang on just one second. Yeah, here it is. I'm sorry, here it is. And it says right here, haze affects shorter wavelengths of light, such as blue and green, more than longer wavelengths like red and IR. I'm like, wow. I could completely see this with my graphs. I'll read it again. Haze affects shorter wavelengths of light, such as blue and green. Green is invisible, more than longer wavelengths like red and IR, which are scattered less. This means that IR light can penetrate haze more effectively, resulting in clearer images in hazy conditions. Haze affects light differently based on its wavelength. The scattering of light in the atmosphere leads to varying disability in color perception. So they've got here green, see, is less than, these two are affected less than the green light. Infrared light penetrates.
And then they've got blue light is scattered the most. Of course, we didn't measure that. This is a side note.
Haze effectively, making it useful for imaging in hazy conditions. That's why, like I guess on a, they always said on a cloudy day at the beach, you would get sunburn worse, maybe. So that was one point from this. We showed that there was haze from our graphs, which is a test, which is actual data, not just let's just look up. Hey, there's chemtrails. I think I see this and that. Now I've got actual data for it. Now, on the 13th, November 13th, which was last Thursday, I believe, I also took some photographs.
And before we get to that, yeah, I want to show one more comparison of these graphs. Oh, and it was 18. God, I can't read that. 1830. Yeah, right here. Okay, just to get a clearer picture. I've got them side by side. The top graph, you see November 13th, chemtrails with green light versus November 16th on a sunny day. Okay, you see how the slope is bigger, more haze. And next one, there's a couple of these. Okay, here side by side on the left, you've got sunny day. And then on the right, November 15th, chemtrails. You see the steep slope here. And 32. This is a little more blurry here, but I don't know, let's get this over a little bit here. Okay. Sunny day. Okay, let's see. And this one. Okay, and this one, November 15th, chemtrails. You see the slope going up. And then here on the right, you've got November 15th, a graph for the red light. So see, it's not, the slope is not going up. This is it's affecting the green light more than the red here. I couldn't read those other two I did. And here you've got the green light versus the IR line is blue. Green light, I try to paint these green with markers. Green, blue, and red. See, the green light's more affected. Sorry for that crappy picture there. And here's the red light on the left. Here's the green light. You see the slope is a lot bigger here. What's this stupid camera is not... I can't stand this camera. And here you got the green light versus the blue light. So the green light's clearly affected more. And now we'll go to some photos. Okay, so on the 13th and... Okay, right over here, I'm going to show some interesting photographs that I caught. We're talking about the 13th and the 17th. Okay, both days they had chemtrails going, which I documented. So let's go to, we'll start with 11/13, 1441, 1441. Okay, see, this is, I'm watching, here's a chemtrail here, and all this is the same, see, 1441. This is leading up to what I saw. 14, is that 51? 14, all of these really, but 1451, no, that's 1441. 1451, unless I said 1456. 1466, I can read this. 14, okay, look at this. This is from chemtrails right here, believe it or not. Alright, which led up to, on our timeline, let's go to 1450 now. 14... I'm sorry, 14... Why can I not read? 14... Here it is. 1450... Oh, we're up here. 14... Just one second. Here it is. I'm sorry. Here it is. Which led up to me seeing a rainbow. Right here. Green, yellow, and pink light. Right there. 1474. Okay. You can see it. I don't know. You can see it better on my end, but it's right. Get my pointer. It's right there. And by the way, what do we see here? A cirrus cloud from, actually that was from a chemtrail, because I saw them lay that chemtrail out. What number are we on? 1475. Okay. And there it is again, right there. 1476. Okay, you can see more clearly, hopefully. 1476, 1477. Okay, right there. And then 1478. Right, now you can see it there. See? And then one more, 1479 on this day. And then you see the rainbow right here in that big wispy cirrus cloud. And now we'll go to the 17th. I'm driving in my car. Okay. 1598 here. Wow. This is after I got to the park. But you see the chemtrails. All this is what they did after I got to the park. 1598 and before. 1598. 1581. 1581. It's chemtrail stuff. And then we got this light here. Look at that. I don't know what that is. 1607. See? You see these lines. This is all them. Okay, now let's go to the rainbows I saw. So, it starts at 1554. Right here. Well, no. This is leading up to it. 1554. Whoops. 1587. Okay. Okay. And then I'm driving along. I think this is after I left. And I'm like, what the heck? And it was I'd just seen one a few days before, which I've never seen these before, except real rainbows. And look at that. It was a smaller one on this little, looks like a circular sun. What number are we on? 1617. Here we go. This is after I got to the park. I'm like, whoa. You can see right here, right over here, all those colors. Look at that. Some kind of cloud, rainbow. Let's see. 1618. 1618. I think I should. Well, there it is right in the corner. 1618. 1619. Look at that. All this wispy cirrus type. And one more, 1556. Oops. 15. Right. Is that right? Yeah. Well, that's just I'm not sure. So, alright. Now, we're at I want to make sure I have enough time because I don't want my file to be too big. So I'm going to stop here and continue on with part 2. So to finish this up. So tune into part 2.